What up, what up, what up, what up, what up, what up, what up? What up, what up, what up, what up, my people? This is your boy, Mr. Bennett here. What up, what up? As you can see, today we'll be finding the gradient of a line. This is a GCSE paper. You know, maths is worldwide thing. So this is a British paper. However, we're gonna shut it down because it do applies to our CSEC. All right. Now, in order to find the gradient of a line, we need at least 2 points, any 2 points on the line, because the gradient is constant throughout. All right. So the gradient is constant throughout. So we could just use a positive one because it's easier to work with positive numbers. Let us take this point right here. Let's take that one here because see it's nice 1, 2. The one here too. All right. So this is the x-axis and this is the y-axis. Now this point, we read the x-axis first. So this is 1, 2. Very important, guys, to can plot your coordinates. All right. All right. Let us look at this one. Change the color because we are we are trying to bring in the color thing, you know, guys. Kind of just make the thing more clearer to you guys. All right. So this is the point 2. So read the x first. 2. Intersection 5. So this is 2, 5. We are going good. We are going good. All right. So we have the 2 points now. So now we can plot. Now we can find the gradient. Now the gradient M is defined as. Oh, I'm going to label it first. This I call that one x2. All right. And y2. Right. So for each coordinate, it has 2x and a y, which we read the x first. Go back up on my color something. When I rush it, you know. All right. So this is x1 and y1. So now, guys, we're going to find the gradient. Now the gradient is defined as y2 minus y1. So it's try something, see if it works. Leave it in the comment section if this works for you, all right? So it's y2 all right? So it's y2 minus y1. See my color code it there. And x2 minus x1. All right. So I'm going to just go straight ahead and put in the values. All right. That is why we need at least 2 points. So we can get the values and then we can shell down this. All right. So let's go. So y2 is 5. So it's 5 minus y1, which is 2, divided by x2, which is 2, minus 1. All right. So let's compute now. 5 minus 2, that's 3. 2 minus 1, that is 1. So the gradient is 3 over 1, or we can write the gradient is 3. All right. So what it means, for 1x, for every 1x we go across, we go up by 3. All right. See there? 1, 1, 2, 3. 1, 1, 2, 3. And it's going to follow that little pattern there, all right? So the gradient, it's only one mark, is 3 over 1 or 3. Let's go on to the second one. As I said, this is a British paper, GCSE. All right. So now again, these are basically the same thing, but this time the points are different. So this is the point. I'm going to take this point. Guys, it's always good to use the whole number points, right? Like we don't want to say 2.5, 4.5. It's easier when you have the natural numbers then. For example, this is the point 2, 5, right? So you know that's solid. 2, 5. and this is 1, 3. Yeah, can't take them down now, so them solid. All right. So this now, we're gonna name this one x2 this time, because I don't want persons to think that it matters which one you name it. So this is x2, y2, and the top one is x1, y1. Guys, remember, it's rise over run, all right? So it's change in y over the change in x. Very important. I don't want none of my subscribers to be putting x2 at the top. That's a common error I find with my students when we just introduce the topic. They will switch it around and put x2 at the top. Don't want that. All right, so it's 5 minus 3. Y2 is 5, so it's 5. Again, guys, I'm encouraging you guys to go ahead and try. I'm going very slow, so you can. And then x2 is the 2 minus 1. Oh, it's 2 minus 1 again. All right, so this time it's 5 minus 3, that is 2. 2 minus 1, that is 1. So the gradient is 2 over 1, or just 2. Because 2 divided by 1 is 2. All right, I want one where we have a negative gradient. Hopefully, they can give us that. They don't give us that one. All right. Which points we're gonna take at this one? This one is only, we're gonna take this point right here, and this point right here. I like these two. All right. So this point is the point -2, -5. Again, guys, go ahead and try. All right. I'm gonna go very slow so you guys can complete it in time. All right, this is the x, this is the y-axis, and on the y-axis, x is equal to 0. Do remember that, guys. X is equal to 0 on the y-axis, and on the x-axis, y is equal to 0. All right, so let's go ahead. This is the point 0, 3. So let me just put that here. 0, because x is 0 on the y-axis. And as I marked earlier, this is the point -2, -5. So which one we're gonna name? X2, X1, it doesn't matter. We're gonna name this one X2, Y2, X1, Y1. All right, it does not matter how you name it. All right, so let's formula now. The gradient M is equal to Y2 minus Y1 divided by x2 minus x1. I keep putting in the formula because I want you guys to get it. I want it to sink in. All right, our x2, our y2 is -5 minus our y1, which is 3, divided by x2, which is -2 minus 0. So let's compute now. -5 minus 3, that gives us -8. And the -2 minus 0 is -2. So our gradient M is equal to 4. The negative cancel the negative. So the gradient is 4. All right. So every 1x across, you have a 4 up. See there? 1x, 1, 2, 3, 4. 1x, 1, 2, 3, 4. That little part. Oh, see, this one can show you. See there? 1x, 4y, right? 1, 2, 3, 4. That's when it's gonna each at the whole number. So very important for you guys to know this. Let me just use the other color and highlight it. You know, Mr. Bennett is all about helping everyone. We're not in this for the fame and the popularity. 1, 2, 3, 4. See there? 1x, 1, 2, 3, 4. 1, 1, 2, 3, 4. to the next. All right. All right, so that is the gradient of the line. We are going to fast forward to some more. All right, this one is different. So let us see if we get a negative gradient. After we do this one, we're going to fast forward the worksheet onto some more pressing things. You don't want to be doing the same thing over and over and over when other stuff is on the paper, all right? So go ahead and try finding the gradient for this one, all right? All right, so this is a solid point right here, yeah, and this right here, all right? So this is the point 1, 1. And this is the point 0, 4. Remember, x is 0 on the y-axis. So this is the point 0, 4. So we're gonna call this one y2. So it's 1 minus 4. Notice I don't write the formula again, all right? And this is 1 minus 0, all right? So 1 minus 4, that's negative 3, and we get positive 1. So here we have it, guys. This is equal to negative 3. So the answer for this is negative 3 or negative 3 over 1. So what we can observe from doing that, let us go back up. When the graph run from left to right, look at this graph, right? It's from this go up, so, right? This one is different. We get a positive gradient right here. And then this one now, when it turns this way, from left to right, down, going downwards, we have a negative gradient. So guys, it's very important. I've seen where persons from UTech, they ask them that. They draw a line and say, is it a positive or a negative gradient? So when it run goes so, the gradient positive. When it comes so, the gradient negative. And we can see that, right? We did 3 of these and the gradient was positive, and then we did 1 of this one and the gradient is negative. All right, so let us see. Now I want you guys to try this one. I'm not gonna do this one until you guys try. Come on, put it in the comment section. Let's go, let's go. All right, what did you guys get? All right, which points we taking? Which points did you take? All right, we can take them. All of these are basically solid points on the line, meaning they intersect at a natural number. All right, so we could use a positive now. No, there's no positive alone. All right, so we could take that point here. This is the point negative 1, 2, and we're going to take this one, negative 4, positive 5. All right, so this, we could call this one our x1. Again, it doesn't matter what you name it, is x1 or x2. I could have named this one x2, y2, it does not matter, all right? We get the same answer. As I say, the gradient is the same throughout the entire line. All right, so it's y2, or whatever I put in the points now, it's a negative 1, positive 2, and this is negative 4, 5. Remember, guys, read the x-axis first and then the y-axis, where the intersection. My grade 7 students used to do this. You guys know a tutor at every level. So people who want to link me, just link me. All right. It's the intersection, right? All right. So let's go now. So y2 was 2 minus y1, which is 5, divided by x2, which is negative 1, minus 4. Very important, guys. Minus is a part of the formula. Remember, it's y2 minus y1. A common error that I found with my students is that they will put, when it's negative, they just put the 1 negative. Lack of concentration. They have to concentrate, guys. All right. So this becomes a 2 negative, becomes a plus. I'm just going to change the color just to show that it is plus now, right? This becomes plus. So it's 2 minus 5. That gives us negative 3. So we're going to have negative 1. Let me rewrite it here because some people now see it. You know, this becomes plus, guys. 2 negative. A negative multiplied by a negative give us positive. So this will give us positive 3. Again, the gradient is negative 1. Once the graph run like this, we have a negative gradient. If it run like this, we have a positive gradient. That's an observation, very important, especially when you go to university. You will be required to do that. So the gradient is negative 1, our answer. All right, we're gonna fast forward now to other questions. This is number 5, so I'm gonna fast forward to some other questions that has different kind of scenario. All right, I don't know if I have anything though. All right, guys, so let us look at number 7. No, they did not give us the line. What they did was to give us the 2 points. So this is nice and easy. We can actually get the 2 points. We get the 2 points, so we can go ahead and label them. All right, so we can label this one. Again, remember, it doesn't matter, x1, y1. This is what we did in class. We got Damien Hines, still owner the credits. All right, and then x2, y2. All right, so it's nice and easy. We can just, let us put back the formula. M is equal to y2, and this is the x2. Guys, I'm just color coding it so persons can see. See it? But now holding that here, you know. See, now holding, you know. So work with Mr. Bennett. All right. I'm telling you, know, work with me. All right. Now charging. This is free. All right. So this will be 10 minus 1. See color code there? The color blind. Oh, so 10 minus 1. And then x2 is 5. So it's 5 minus 2. So this is 9. And 5 minus 2 is 3. So the gradient is 3. And that would be our answer. Let us do one more of these, but I want you guys to go ahead and attempt it. All right, find the gradient of the line that passes through the point 5, 4, and 7, 0. Go ahead and do that. Come on, let's go. 2 minutes, 2 minutes, 2 minutes. Let's go. Let's go. Let's go. Let's go. Push yourself. Push yourself. Push yourself. Let's go. Let's go. Come on, guys. You have an exam to pass. Big up all over the GCSE and ICGSE, something like that. Don't quite remember the examination. Come on, guys, let's go. You have the 2 points. Name them x1, x1, and y2, and do the thing. Do the thing. Gradient is rise over run, changing y over the changing x. Let's go. Come on, let's go. No lazy thing around here. I'm saying anything. I don't know lazy thing, you know. Global, this are going up, peeps. Global channel, you go. Come on, you can do it, guys. You can do it. All right. And this is worth 2 marks. Not sure why it worth 2 when they give you the points. But anyway, I could call this one x1, y1. X2, y2. All right, so we can start. So it's right about the formula again because it's a man me like when people learn. So y2 was 0, so it's 0 minus 4, and then you have 7 minus 5. So 0 minus 4, that is negative 4, and 7 minus 5 is positive 2. So the gradient is 2, negative 4 divided by that is equal to negative 2. All right. Very easy, nice and easy. All right, so we're gonna go on to a different type of scenario where, and let's shell down the place. So anything normal. All right, guys, so different scenario. They say that the line AB passes through the points A, 2, negative 1, and 6K. So we don't know what is K, and they say the gradient of AB is 5. Work out the value of K. All right, let us, I'm particularly pleased with this one because it just requires a little bit of thinking. It's not hard. Just go back. In mathematics, always go back to what you know, all right? We know that the gradient M is defined as y2 minus y1 over x2 minus x1, all right? So what we do know now, we know that the gradient is very different for, all right, so we know that the gradient is 5. So therefore 5 is equal to, what is y2? We can label them, you know, so people can see x1, y1, x2, y2. Big up my son Sanjay Bennett. All right, so what is y2? We don't know. Okay, so we put k there. Minus y1, which is negative 1. So we have another minus 1. All right, and then now this will be 6 minus 2. We'll simplify now. 5, as shown earlier, this will become positive, so it's k plus 1. And 6 minus 2. What's 6 minus 2, guys? That is 4. All right, so now we're gonna solve for k when I get rid of this 4 and this 1. So we have to take the inverse. All right, so we multiply, when we use a different color ink, to get rid of divide by 4, we have to multiply by 4, which is the inverse. All right, so it's times 4. So that gone, that gone. But now what we do to one side, we do to both sides. So let us rewrite. No, we're not rewriting nothing. All right. So yeah, we have to rewrite it, please. See here. So we're gonna left with 5 times. Oh, this is 4. Sorry. We're gonna left with 4 times 5 and k plus 1. All right. So what is 4 times 5? That is 20. And this is k plus 1. Now remember, our objective is to get k by itself, right? So let's go. We're going to take the inverse of plus 1. Somebody said it. You got it correct. That is minus 1. What we do to one side, we do to both sides. So it will be 20 minus 1. And therefore, we get k. All right, I'm gonna just check this answer just to ensure that it is correct. As me a human though, I can make an error, right? All right, so let us put 19 right here. Let's see if we get the gradient to be 5. All right, so we know that it is 19 minus 1. Yeah, this must give you 5 now, guys. All right, 6 minus 2. If you not get 5, we know we made an error. So 19 plus 1, that's 20. And 6 by 2 minus 2 is 4. 20 divided by 4 is 5. So it is indeed correct. Guys, my me glass catch me. That means me are gonna get money. That's what my granny tell me. All right, so you guys are gonna do 17 for me. All right. The line, oh, let me go up some further. The line AB passes through points -4, -3, 4, and K12. The gradient of AB is 4. Work out the value of K. All right, guys, let's go ahead and do that. Let's go. Let's get started in here. Come on, let's start it in here. Let's go, guys. Work out that, guys. Three minutes to do that, guys. 3 minutes. With maths, you have to time yourself. All right. Let's go. All right. Come on, guys. Let's go. Let's go. Let's go, guys. 1 more minute. 1 more minute. Let's go. Let's go. All right. All right. This in the meantime, we know that gradient M is equal to y2 minus y1 over x2 minus x1. All right. And we can call this x1, y1, and this x2, y2. All right, so let's put in what we know. We know that the gradient is 4. So let's put in what we know. We know that the gradient is 4. We know that y2 is 12. So it's 12 minus x1, which is 4. We know. We don't know what is x2, but we do know it's k. So it's k minus 3 minus 3 a minus 3. All right, guys, so this is going to become a positive. So it's going to be this now. All right, so it's 4. What's that? 8 upon k plus 3. All right, so we're going to multiply both sides by k plus 3. I want to get rid of the denominator, right? But what we do to one side, we're gonna do to both sides. So this is gonna what we're gonna get with 4 times k plus 3, and this is equal to 8. So we're gonna expand the bracket, multiply 4 times k, that is 4k, 4 times 3, that is 12, and all of this is equal to 8. So now let us do this equation. Let us, shall we? So we take the inverse of plus 12, which is minus 12. What we do to one side, we do to both sides. All right, so we're left with 4k is equal to 8 minus 12, that's negative 4. And there we can see the answer is going to be, take the inverse of 4 times k, which is divided by 4. So k should be equal to negative 1. Let us try and see if it's correct. Remember, Mr. Bennett is only human. Guys, I just got this worksheet, so you know the trips already. Let us check if it right. All right, so this is supposed to be minus 1. So it would be 12 minus 4. Yeah. And then now minus 1 divided by minus 1 minus 3. So no right so. So no right so in a ninja man voice. All right, so 12 minus 4, that is 8. It's not right, guys. It's not correct. Something went wrong. Oh, you're right. It's a minus 1. So this is going to become plus 2. Yep. See, me need to make the error Mr. Students always make. All right. So this is going to become plus. So this work out to 2. So it's going to be negative 1 plus 3. This work out to positive 2, and 8 divided by 2 is equal to 4. So there we have it. Thank you guys so much for watching the full video. And I want you guys to leave this one in the comment section. All right, guys, big up on yourself. Please, guys, share the video with others so they can benefit too. A lot of persons need help. So Bennett is willing to help all. So please just ensure you do your little part. Just share the video. That is all. Tiny video. That is all. Mr. Lennox Bennett is out. No doubt. Thank you guys so much. Mr. Bennett, appreciate you all. Big up to the people them who are still my videos. At least you know quality. So Bennett, appreciate you all. Guys, please ensure you leave this in the comment section. You are appreciated. This is Mr. Bennett. I'm out, no doubt.